Hi guys, welcome to section D. We're going to talk about caves today. Super cool. So this is actually the inside of a real cave. I don't know where that one is though. So a cave is a naturally occurring, basically just huge gap in the ground. This is underground, and it's an empty cavern, an empty space, and it's a naturally occurring incident. Most caves are what are called solution caves, meaning that they were formed when water passed through them, the solution of water. And so they typically are formed in these stratuses of soluble rock, meaning that the water can actually kind of dissolve it away, things like limestone, okay? There's a few theories on the involvement of acid, though. And if you look on page 416, it talks about some of the current theories, and it gets into kind of the biblical lenses with this too. And so one theory is that carbonic acid, which comes from rain getting into the groundwater and doing that. But another theory talks about the possibility of an even stronger acid actually coming up underground and getting into these cracks, and kind of eroding away these huge caverns. That theory tends to be a little more accepted, and that theory also fits really well with the flood, with Noah's flood, with all the movement of the plates. There was a lot of water, according to the Bible, bubbling up from underground. The plates are moving, so it stands to reason that there'd be all kinds of, not just the volcanic activity, the magma, but if there's acid down there, then the acid would come up too and shape a lot of these caves then as well. I don't even know how to pronounce this. Speleologist. Let's go with that. These are the scientists that study caves. Okay, and spelunkers. I can say that these are just people that explore caves. That is probably a spelunker right there. And depending on the cave, you can walk through it. Sometimes you need to have like climbing equipment. Sometimes you need to swim through it. A lot of caves are totally dry. The water has already left, but sometimes, like in this situation, there's actually still some pools left, and sometimes there's streams and things that still flow through. I was in a cave once that had a moving stream, and the bottom of the stream looked like marble. It was really cool, and it was super white and bright, like the marble that you might have on your countertops at home. And the rest just looked like brown dirt and stuff. It was super cool. Okay, so we've got some common features in these caves, okay? These speleothems are deposits of minerals, okay? So as the water comes through, it dissolves a lot of the rock and it has a very high mineral content, okay? And so part of the features that are there are what's left behind, but a lot of them are actually developed by water dripping or flowing and leaving these mineral deposits, okay? The most common mineral that's deposited is calcium carbonate, okay? Flowstone, also called dripstone, is formed with just a small trickle of water. It could be dripping from the ceiling, it could be flowing on the ground, it could be kind of running along the ceiling of the cave. And as the water is moving, it's carrying those mineral deposits with it. And it kind of deposits that sediment along. When the water evaporates, those mineral deposits get left behind, okay? And we have some common flowstone formations here. The stalactites, these up here are the stalactites, okay? T for top. They're like icicles that form from the ceiling. They form from the top, and the water is dripping down, and it leaves that mineral deposit behind as it drips, okay? But as it drips down, it takes some mineral with it and starts building it up on the floor. And those are stalactites, okay? So these down here, they always kind of match up, okay? So this stalactite is leaving the mineral deposits behind, but then it drips down and it forms this one down here, okay? Now, if that happens enough, they'll actually meet and you get like this continual growth, this continual feature right here known as a column. Let's see. The rapid formation has been done in labs before. You see this in nature as well. The wetter the cave, the more water there is, the more the deposits there's going to be. If it's a totally dry cave and there's no more water, it's incredibly slow, which is where these older scientists get the idea that these caves must have been, requiring thousands and hundreds and thousands of years to build their deposits. But when there is actually water there, it can build up much more rapidly. This other feature, I don't know if you can see that right here. It's a much thicker, it's called a drapery. It's almost like a curtain. And so you can see on the next page, this right here is a drapery. This is known as cave bacon, and the light's shining through it. Doesn't it look like a giant piece of bacon? Super cool. These are two pictures that I took. These are in Crystal, sorry, not Crystal, that's in California. These are Carlsbad Cavern pictures, and you see, it almost looks like a frozen waterfall. There must have been water there at some point, and it leaves all these crazy deposits behind. Here's some stalactites from the top. This is like a giant column. Some of these formations are called clouds. There's just all kinds of crazy stuff. Super cool. If you get a chance to go into a cavern, absolutely do it. So all this stuff, all these features, all these caves need to be mapped. Okay, and this is known as karst topography. And all these formations that get left behind have names. It's like the topography up on top of the surface. This is the topography kind of beneath the surface, and it's all from this erosion and the wearing away. Some common features, karstic is just what we call these features. So karstic features are related to this karst topography, okay? And so some common karstic features are sinkholes, all right? So you can see this sinkhole right here. This was at one point solid, and this area down here would have been a cave. Okay, it would have been a big, massive opening. If the opening gets too close to the surface and the surface is thin, it will collapse, okay? And that's what causes a sinkhole. We also get these things known as natural bridges, okay? So if part of the ceiling collapses, but part gets left behind, where I've got this red drawn here, if it collapsed on this side and this side of it, it might leave a little bit of the ceiling behind, and that is a natural bridge. Okay, so we can see some pictures here. This is a sinkhole. This is a huge sinkhole that actually goes really, really far down. So there was a huge cave down there. It was this natural opening from water at some point. The road was built over it, and then the weight just became too much, and everything falls in, and you see this huge open space beneath it. This is a natural cave. So this was the ceiling of a cave. This whole area was enclosed. This space would have been completely underground. What's gone collapsed at some point, and just this was left behind. This is another natural bridge. This is up in Northern California, and this goes on. This looks like a dark cave if you go in here, but you can actually go through that and get to the other side. So the natural bridge is probably about a football field or so long. I don't quite remember. I actually walked through that, and it is super cool, kind of scary. You walk through the water, and it gets about chest high, and like there's really nothing to hang on to, and it's dark, and you finally get through to the other side, and it's open on the other side, and it's known as a natural bridge. That's up by Lake New Melones in Northern California. Super cool. I don't really remember what it's called. Angel's Landing or something like that. I don't know. Ask me in class, and I'll help you look it up if you're interested. Good stuff out there. Go take a hike. Bye-bye.